The observable universe refers to the part of the cosmos that we are capable of examining and analyzing through the use of telescopes and other scientific instruments. However, this ability is inherently limited due to the finite speed at which light travels. Since light serves as our primary means of gathering information about distant objects and events, we can only observe phenomena that are within a certain range from Earth. Events or objects that occurred too long ago or are too far away remain beyond our reach because their light has not yet had enough time to arrive. Present estimates place the diameter of the observable universe at around 93 billion light-years, which is vastly greater than the estimated age of the universe, approximately 13.8 billion years. This seeming inconsistency arises from the universe's ongoing expansion, which has caused distant objects to move apart and their light to take even longer to reach us. Despite how expansive it is, the observable universe remains a mystery in many respects. Nevertheless, advancements in technology, such as NASA's James Webb Space Telescope and other sophisticated instruments, have enabled scientists to uncover more about the universe's makeup, its formation, and its many phenomena. The James Webb Telescope, in particular, has recently identified a fascinating cosmic structure at the far edges of the observable universe. If you're curious about the latest space discoveries and cosmic developments, consider subscribing to our channel, liking this video, and turning on notifications. As we consider what may lie beyond the boundaries of the observable universe, we encounter questions that push the limits of science and imagination. Traveling to these distant realms would require revolutionary transportation technologies capable of bending or transcending the fabric of space-time, concepts such as wormholes or space-distorting engines. These ideas have long been subjects of scientific speculation and debate, with many physicists questioning whether faster-than-light travel is even theoretically possible. Even if such methods could one day be realized, the technology and intelligence needed far exceed our current capabilities. The theory of cosmic inflation suggests that the entire universe could be at least 10^23 times larger than the portion we can observe. This figure is so enormous that it is beyond human comprehension. Since we lack the means to see or measure beyond our observational limits, we can't say for certain what exists outside. Still, that hasn't stopped scientists from formulating hypotheses based on data from the farthest reaches of space, an area where NASA plays a critical role. In collaboration with other space agencies and research institutions around the globe, NASA has significantly expanded our knowledge of the cosmos. Before the James Webb Space Telescope began operations, the Hubble Space Telescope already provided us with breathtaking images of the universe's deep field. Once launched, the James Webb Telescope was directed toward the most remote galaxy ever observed, capturing stunning images of numerous galaxies shining from the distant past, appearing as they were just a few 100 million years after the Big Bang, roughly 13.8 billion years ago. As the universe expands, the light from these early galaxies stretches to longer, redder wavelengths, a phenomenon known as redshift. This redshift allows the James Webb Telescope to observe them in infrared, revealing galaxies as they were in the early stages of cosmic history. The telescope's findings include detailed observations of faraway galactic fields and provide vital data about how rapidly stars were forming in those early epochs. These revelations have uncovered a surprising number of galaxies already producing stars shortly after the universe's birth. Such discoveries provoke deep reflection about our place in the cosmos. For centuries, humanity has wondered whether we are alone in the universe. Recent observations suggest that if the observable universe is this vast and populated, the unseen universe could hold millions more galaxies. This notion is both astonishing and humbling, igniting a sense of awe about the grandeur of the cosmos. Could intelligent life exist elsewhere in the universe? The idea is increasingly plausible. Thousands of planets beyond our solar system, known as exoplanets, have been found using techniques like the transit method and radio detection. Some of these worlds share similarities with Earth and may be capable of supporting life. A significant finding related to this possibility comes from the James Webb Telescope's study of the exoplanet WASP 96b. The planet lies outside our solar system and analysis of its light spectrum revealed the unexpected presence of water vapor. Furthermore, the data indicated the existence of clouds and atmospheric haze, conditions once thought unlikely for habitable planets. Given the many environments that seem potentially suitable for life and the rapid progress in exoplanet exploration, it's becoming more difficult to dismiss the possibility of extraterrestrial beings. Although there is no conclusive evidence yet, the accumulating discoveries point to a universe teeming with potential. Now consider the idea of a multiverse in relation to the observable universe. The concept of the multiverse, also known as the many worlds theory, suggests the existence of parallel universes or alternate dimensions beyond our own. This theoretical framework is rooted in quantum physics, which explores the behavior of the smallest particles, such as atoms and subatomic elements. In some interpretations of quantum mechanics, the mere act of observing a system causes it to collapse into a single state. But the many worlds interpretation posits that each possible outcome of a quantum event actually occurs in a separate, branching universe. Though highly speculative and not supported by definitive proof, the multiverse theory captivates many scientists and philosophers. It offers a compelling way to explain otherwise perplexing phenomena, yet it remains controversial. Some experts embrace the concept as an intriguing avenue for understanding reality, while others remain skeptical due to the lack of verifiable evidence, like Schrödinger's cat or the enigmatic nature of darkness. The multiverse remains a thought-provoking idea, one that invites curiosity, but demands much more investigation and validation. Another mysterious cosmic puzzle is the phenomenon known as dark flow. First introduced in 2008, dark flow was proposed to explain observations that some galaxy clusters appear to move at speeds that exceed predictions based on the known distribution of matter. This idea suggests that these clusters might be influenced by an unknown force, possibly dark matter or dark energy, pulling them in a specific direction. However, dark flow is still a contentious subject within the scientific community. Some research supports its existence, pointing to a large-scale structure beyond the observable universe that may exert a gravitational pull. Other studies, however, have failed to replicate these findings and instead attribute the observations to measurement errors or alternative explanations. While the possibility of dark flow is intriguing, we cannot yet confirm its reality. More research is essential to determine whether this phenomenon is genuine or simply an artifact of observational limitations. What are your thoughts on these cosmic mysteries? Share your opinions in the comments section. Don't forget to like, subscribe, and turn on notifications for more updates on the universe and beyond. See you in the next video.